Hello everyone and welcome to another edition of Triangle Investor Interviews. I'm your host Lucian Valkovic, and before I announce my guest, just a reminder of a disclaimer. This interview and all my interviews are not a recommendation to buy, sell any shares, products or services. Always do your due diligence and consult with your financial advisor. I'm joined today by a serial entrepreneur, mechanical engineer, and engineering managing graduate from the University of Nebraska and Lincoln. He's the founder and CEO of Hadron Energy, Mr. Samuel Gibson. Sam, great to have you here.
Yes, thank you so much. It's great to be here and very excited to chat some more.
Definitely, you have some interesting things over there, and I would like to unpack a bit about that. Actually, my audience would like to hear more about the technology you have. Let's start maybe with you, and actually with your background and your journey. You founded a successful company at age, I believe, 22. So really, congrats. You achieved 4 million in revenue in only a few months, right? So what key lessons from that experience shaped your approach and that started Hadron Energy?
Yeah, of course. So, first, I think it's important to share where I sort of come from. I'm originally
Please.
from Sioux Falls, South Dakota, and my background growing up was in HVAC. So, I did everything with HVAC from manufacturing to servicing, and that eventually led me to get my mechanical engineering degree. So very early on, I was very engaged in this sort of industry. So then, when I graduated college, I decided I wanted to start an HVAC service company, and this was a result of many years of actually working in the industry. We raised some good capital from private equity, and you know grew that company from 6 to 18 employees. And as it states there, yeah, we did that in 8 months. So it was a very fast turnaround, and I think it just comes down to providing amazing customer experiences. We grew it from zero to $4 million in revenue, and at the end of the day, I was working on cooling for data centers. And what I found when I was working in the industry was the cooling is always there. It's definitely a big challenge for these large projects, but I was more passionate about power and specifically nuclear power. So my experiences building my first company were monumental and very important for me to understand the company building process. Um, Now, I was actually involved with the American Society of Mechanical Engineers, where I founded the student chapter and grew that from 4 to over 200 members in college. And then I wanted to replicate that in the real world, so that's when I started the HVAC company. Then, once I exited that in May 2024, I decided that I wanted to chase that big dream. And for me, that was building mass manufacturable micro reactors to solve the energy crisis. So, again, the skills that you learn are actually very transferable across industries, especially related to mechanical equipment and how it relates to nuclear. So, that's what I would say really helped me, and it's all about just getting the experience, I would say.
Yeah, that's a great story, and you're pretty modest. You didn't mention that you have been recognized with prestigious awards, few of them actually. So, how did those accolades impacted your credibility and approach to leading Hadron Energy?
Yeah, that's a really good point. In these ASME awards, so I was awarded two global engineering awards through ASME, and that definitely gives me a little bit of credibility when um, I'm recruiting engineers, when I'm talking to investors, because you know the external sort of credibility that provides is very beneficial to building the brand. And at the end of the day, it's really all about how you can build a great brand. So that's what we're excited about. And there's a lot of other sorts of awards that we are working on as well, which is really exciting. So I'm looking forward to sharing some more of those. But yeah, it definitely helps our position and our case to work with the best people and communicate that with investors and partners alike.
Okay, let's meet your technology. Your company is developing patent-pending micro-modular reactors to provide clean, scalable energy. Can you describe the product? Can you walk us through that project? How some specifics? Give me some color on the product.
Of course. So what we are doing at large is we are building a light water micro-modular reactor. And what that means is all 94 nuclear reactors in the United States are cooled by water. What we are doing is essentially a fraction of the fuel assemblies in a large reactor to then make it in a very small package. And in this small package, we can actually mass manufacture them, as I was mentioning, to then ship to the site. We want these reactors to be portable. When they reach the site, they're able to be installed relatively in a straightforward manner, which reduces construction risks. And historically, what has been a challenge for the nuclear industry is construction overruns as well as budget overruns. And we're trying to solve that by having a smaller package that we can control a lot more of, say, for example, the supply chain, which the supply chain right now, that's of course something we can get into in a little bit. But at the end of the day, what this reactor does, it's a pretty fancy way of just essentially boiling water to then produce steam that basically is converted into carbon-free power. And the best thing about it, of course, as folks probably know, is it has the highest capacity factor of the energy forms, which is very important because for these new data centers or other forms of power needs, such as manufacturing capacity, 24/7 baseload power is incredibly important because it's always there, it's always on. Whereas, for example, wind and solar is only on about 25% of the time, or producing maximum power 25% of the time. Wind is 35%. So we are offering nuclear at a smaller package to try to reduce the barrier to entry. And our unit produces 10 megawatts of electric power. So there are many, many use cases, but ultimately we want to service data centers, remote communities / applications, and eventually government bases and things like that.
Yeah, when you talk size, how big is it?
Yeah, so in terms of the dimensions, right now the core itself, and this is our primary focus right now, is we're just designing the reactor. There are, of course, components surrounding it, such as the turbine, generator, cooling system, and so on. But the reactor itself, we're estimating, is at this time about 1 meter in diameter and approximately 2 meters long. So it's very, very compact.
That's really great. I would like to hear more about the safety features of that reactor. And of course, the fuel cycle. I believe it is a 10-year fuel cycle for those reactors. Can you tell me more about that?
Yeah, so first I'll touch on the safety. So the safety, of course, is paramount. It's incredibly important for our company and obviously the industry as a whole. So us being light water, we have multiple fail-safes in place. And if you look at the operational history of light water, pressurized water reactors, they're actually incredibly safe. And one way we can make our reactor very safe is We show, for example, on our website, the reactor being transportable. When it gets to the site, we want to install them vertically in the ground so that the shielding is actually very robust. And it being sort of out of sight, out of mind, makes it far more secure, safe, and of course, we're going to have our containment facilities to where there's not going to be any radiation, for example, in the surrounding areas. So that's what's really important to know is these reactors are incredibly safe. And on top of the reactor, we will have a pool of water as well, which means if there is like a worst case scenario accident, we can flood the reactor with water and it is walk away safe, which means for us that we feel very good about our safety. And that is essentially, again, the worst case scenario, but there's multiple fail safes ahead of that would occur. And then in terms of sort of the other question, the fueling side is very exciting right now. You're correct that we are targeting right now a 10-year refueling cycle. Now, we are looking at HALEU fuel, which high assay, low enriched uranium. In that supply chain right now, it's going to be, I think, a little bit longer before that type of fuel is ready. So we're also looking into about 10% enriched uranium, which is considered LEU plus, low enriched uranium plus, because historically, like reactors today use about 5% enriched uranium, and the benefits of having higher enrichment mean a more efficient reactor. It also means you can make the core a smaller size. So what we're trying to do is find that happy medium of where can we find this great enrichment level that is available, and this is a problem that we're working on right now.
Understood. Your research spans mechanical engineering, nuclear engineering, and material science. What breakthrough in these fields are you most excited about that could accelerate the development of the microreactor?
Yeah, it's a really good question. So I think what I find the most interesting is simply the form factor, to be totally honest. Is the form factor we are doing has never been done before commercially. Now, that does require a lot of innovation on the material science side of things, because historically, and what we're looking at right now, and I actually had a conversation with an investor yesterday about this, is the shielding and the special materials that are required for shielding for our containment structure. So I would say, honestly, the thing that I'm most excited about is how we can engineer this to be a small package, and especially related to the new innovations we're going to have to see on the material science side.
Yeah, one other thing, the nuclear industry has historically faced challenges like budget overruns and public skepticism. How do you approach this? Okay, you touched on the budget part, okay, but what about public skepticism?
Yeah, very interesting question here, because I think at the end of the day, I was looking into it yesterday. To give you an example, in the United States, there's approximately 14,000 nuclear engineers, which, if you look at the entire population of the US, that is such a small fraction of individuals who really know this technology very thoroughly. And the reason I'm mentioning that is, I think really what it comes down to is the education behind it, because if more people basically understood the technology and how it compares to other forms of technology, then they would feel very comfortable and confident in its potential. So I think it really comes down to educating the public, and that's something I try to do to the best of my ability, and I know others do that as well. So that's what we can continue to do. But I will say one quick note is, it's now shown that in America there are 62% of Americans now support nuclear energy, which is great. And this is what we need to continue to see.
Yeah. Sam, in the perfect world, when can this reactor be operational?
Yeah, so if you're talking about our demonstration unit, or are
Yes.
you yeah, demonstration. So we actually just located our demonstration site, which is really exciting. We'll have a formal announcement of that very soon. And what that looks like is we have to make some final design iterations, which, takes a little bit of time. We don't want to rush this process before we're ready to manufacture components, but in an ideal world, we're going to be manufacturing components at the end of this year, 2025, or procuring components even, to where by the end of 2026, we could have our working non-nuclear prototype. So that's basically what we're working towards. And then in terms of licensing and timelines there, we are seeing some pretty interesting things in the market right now. Especially, I just was at the NRC a couple days ago. So once we have that non-nuclear prototype, then we can then basically accelerate through the licensing process, from my understanding, providing the data that our non-nuclear prototype provides. So by the end of 2026, we'll have that complete, and then we have seen that approximately 18 months, if we have a very complete design and application to the regulator, we can then have our license at the end of that 18 months.
Okay, you've grown your team from 1 to 8 in only 2 months and added 2 experts on the board. How do you attract top talent to a startup in this highly specialized nuclear energy sector?
That's a really good question. So right now, in total, I believe we have 10 people full time, and in absolute total, in terms of part time, contractors, things like that, we have 24 people. And what we've been able to do in a year, we just hit our 1 year anniversary, I think is very exciting. At the end of the day, people see our approach, like especially industry veterans, and they say this is a very logical approach. We think this is going to work, and we can see the roadmap ahead, which is why people get, pretty excited about it. So I would say it just comes down to the way that I get most of these amazing people on the team is I go meet in person, I go to conferences, and I meet a lot of people to then share what we're doing, and then naturally some become interested and we start working together.
Yeah, when you mention conferences at the World Nuclear Symposium, you engage with global leaders and the US Nuclear Regulatory Commission. How are these relationships shaping Hadron's regulatory and commercial strategy?
It's a really good question, and these relationships are absolutely critical because at the end of the day, the industry has been waiting for a time like this, and they've got all this amazing talent in the industry that are ready to work and ready to put in the work required to get this stuff done. So I think it's all perfect timing, and having these connections definitely accelerates the process. And that's what we need at this time to start decarbonizing, to have baseload power, is to basically get these things to market.
Okay, looking 5 years ahead, let's take the longer term approach. What is your ultimate vision for Hadron Energy? What is your goal here? Do you hope to transform the company into something bigger than this, or what's the plan? Of course, you expect to grow in the process, but what is the long-term plan?
Yeah, so the long-term plan, I would say within 5 years, we want to build in public as much as we can, meaning what we can share right now, of course, but also in 5 years, I think we can, position ourselves to potentially even be maybe a public company. And at that point, the reason I'm mentioning that is I want to really accelerate the growth and just, again, the deployment of reactors. And I think connecting to people on a very large scale, sharing the story and the mission is incredibly important. So I think today where we are, total we have 24 team members. In 5 years, I mean, we achieve a lot in a year, so it's kind of hard for me to think that far. So I would say we're probably going to be a few hundred people at the very least within, 5 years. And at that stage, what I would like is to have a fully scaled manufacturing facility, to then think of it as the Hadron Gigafactory, where we're mass manufacturing these, shipping them in the United States and around the world, to then deploy. And basically what I want to have as a core mission is on our website, eventually when we start deploying reactors, I want to have a counter of how many tons of carbon emissions we're saving by all of our reactors. So that's something I'm really excited about.
Yeah, definitely. Final question: what were or what are the biggest technical or regulatory hurdles that you had or you anticipate in bringing this technology to market?
That's a really good question, because in building the design itself, really what the entire reactor is built around is the core, is the core of the reactor. And this is what I've found is, we need to continue to iterate on. There's no perfect answer. There's always trade-offs in how you design something. You might gain efficiencies or lose efficiencies, and then you have to see how that affects the cost to make that, component. So I would say this is the most challenging thing, because surrounding this nuclear core, we have basically a lot of mechanical equipment that, again, falls into place around what the core specs are, essentially. So that's what I would say technically is the biggest thing that we're working on right now. And then in terms of licensing, we actually feel very good about the licensing, because we are, again, a light water reactor, which the Nuclear Regulatory Commission is very familiar with, and especially when we take it to other regulators around the world, they will also be familiar with the technology. So it really just comes down to us preparing a very, very thorough application. And once we do this, we feel very confident that, we're going to see the result that we hope for.
And I wish you luck with that, with your path to the future. That was Sam Gibson. Sam, thank you very much for this chat.
Yes, thank you so much. I really appreciated it.